So the other thing that we do with trig identities is we rewrite and simplify them, and we prove identities with them. So that's basically our next phase here. So let's first look at rewrite and simplify, and as we see in proving identities, it's almost the same thing, except we just know that I want to simplify this to that, etc. So it's kind of all in the same hat. So in terms of rewriting and simplifying, what we want to do is write in terms of theta and x only. Right now what I have is in terms of my cosines in terms of theta minus a pi over 4, and this one's x plus pi over 3. So we got to clean this up. So essentially we just use our identities. What do we know about the cosine of a difference? Well, that's the cosine of the first angle, cosine of the second angle, plus the sine of the first angle and the sine of the second angle. And so cleaning this up, we know that this, we're talking about the square root of 2 over 2 cosine of theta. That's also the square root of 2 over 2 times the sine of theta. And really probably the only thing to clean this up is we can factor out that square root of 2 over 2, and we pretty much have what they're asking. So I've rewritten this in terms of theta only, and unfortunately I can't go any further because this was cosine squared plus sine squared. I can do more, but this is a cosine plus sine, and we don't have any identities for that. So we'll consider that one finished. It's the best I can do. For the next one, we have the cosine of a sum. So we know the cosine of a sum is the cosine of the plus of the first one, cosine of the second, minus the sine of the first and the sine of the second. And pi over 3, that corresponds to 60 degrees. So again, use your unit circle, or hopefully you've just memorized it by this time, right? This cosine of 60 degrees is 1/2. So we get 1/2 of cosine of x. The sine of 60 degrees is the square root of 3 over 2 sine of x. And here there's at least a half common, so I can pull out a half and get cosine of x minus the square root of 3 sine of x. And again, that's probably the best I can do with that because we don't have any identities for that end right there. Alright, so there's a quick look at probably all we can do in terms of rewriting and simplifying. Of course, we're going to kind of continue that game with the next round here, so we'll do that shortly. Alright, as a matter of fact, how about I do this? Let's we'll approve the identity letter B, because it's a lot like what we just did up here, so I'll kind of do that in one video. So secant of pi over 2 plus x. Well, the first thing we probably want to do is let's start with this side and try to make it look like that side to prove this identity. And probably the first move is to rewrite this using our reciprocal identity. So secant is 1 over cosine. Of course, now what I have is I've got all this action down on the bottom. So what's the cosine of a sum? Well, it's the cosine of the first angle, the cosine of the second angle, minus the sine of the first angle and the sine of the second angle. And then we know that the cosine of pi over 2 is 0, so we have 0 times the cosine of x minus the sine of pi over 2 is 1 times the sine over x. So this basically becomes 1 over negative sine over x, and of course using our reciprocal identity, that's our negative cosine of x. Alright, so that one kind of tied into these top two, where we just rewrote it a couple times, one with the reciprocal identity and then the other with the cosine of a sum identity. We knew what the exact values of cosine and sine of pi over 2 and just kept reducing and simplifying. So there's your first proof. The next three I will do in another video coming soon.